lab. So, for example, if you were here on campus, we would go see one of those over. Dr. Barlow has a lab set up that is sophisticated enough to run those kinds of assessments. We don't have anything like that here in Greyhound Arena, so I steal his biology lab. So that's kind of the way to work out a real heart rate max. Without that facility, we have to estimate it. The easiest estimation is 220 minus your age. Because it's the easiest, it's also the one that incurs the most error. Okay? So there are a couple of slightly more complicated equations for estimating heart rate max that still have error involved, but the more calculation that's involved, the smaller the error. So, for example, one that you can find is 207 minus 0.7 times your age. That's going to be more accurate. There are some, if you look it up on, if you just Google it, there's a 208 minus something times your age, right? So there's a couple of different ones out there that have more calculation involved. The problem with those is, unless you're a super math person, there aren't many of us that can times 0.7 times something in my head, right? So then I have to have a notepad and everything to do that. 220 minus your age is just so simple. But as I said, it has the largest error margin involved, okay? Then what we're looking at is my intensity level. The work rate that I'm doing is a percentage of my heart rate max, okay? So I can work at 80%, or I can work at 50%, or I can work at 65% of my heart rate max. And we can block a range of heart rate, percentage heart rate max as low intensity, moderate intensity, or high intensity. Does that make sense so far?
Yes, ma'am.
Yeah? Okay. Another intensity measure that you'll see very often in the literature is a percentage of my VO2 max. So now I'm looking at my VO2 max is my maximum capacity for oxygen use within my body. Not oxygen that I'm breathing in, but oxygen that is being utilized at the cellular level, okay? So you'll often see percentage VO2 max or percentage VO2 peak. They're relatively similar. As far as we're concerned, we can count them as similar. And this chart here is a useful tool because the thing about VO2 max is I can't just measure that when I'm out on the track running or riding my bike, right? Where I can measure my heart rate, I don't have any way of recording how much oxygen I'm using, right? You need a spirometer and a computer unit to collect that kind of data, okay? So on this chart, it gives you percentage VO2 along the bottom and percentage heart rate along the y-axis, and you can see that there's a strong linear relationship between the two. So this allows you to convert. If you've got a training program that you have downloaded or you found in a book or a magazine that is the intensity level that you have to work at in that program is set in percentage VO2 max, you can convert it to a heart rate max sort of thing. Another way of doing percentage VO2 max is to use your heart rate and turn it into the equivalent of a percentage VO2 max. So this is called the Carbonan method or the heart rate reserve method. Okay? So here you are going to use your heart rate to estimate the percentage VO2 max that the training program gives you, right? So the heart rate reserve is your heart rate max minus your heart rate at rest, and then you use a percentage of that heart rate reserve to estimate percentage of VO2 max. So you can organize a target heart rate, you can organize a training heart rate range. And on page 386 in your textbook, they give you a nice example of this. Right? Your training heart rate, when we get to, let me write this equation down for you, hold on. I need the whiteboard. So training heart rate equals your heart rate at rest minus your percentage heart rate reserve. Okay. So this is pretty accurate. It's a good way to use heart rate to estimate VO2 max. I just, personally, I don't know why I would do more work mathematically when I've got the option to use percentage heart rate max. As I said, it might be easier than trying to convert percentage VO2 max into percentage heart rate max if that's the measure of intensity that a program you have is using. You know, but if we go back here, right, if I'm working with a 20-year-old, then, and I use this more accurate equation, then his heart rate max is going to be about 193 beats per minute, give or take, right? 77% of that is 148.6, so 149. 90% of that is 174. And so I can say to him, okay, go out and run today and keep your heart rate between 149 and 174. That's the training zone I want you working in for today. And it's so simple, right? So I like to keep my life simple. I don't like to make things more complicated than they have to be. Okay? Any questions on those two? Okay. The next measure that you'll often see is not physiological. So this is not one that I would recommend you use for your log, because the guidelines specifically say a physiological, because I want you to practice with the idea of a true physiological measure, right? What is my body telling me I'm doing? The Borg scale and others are called ratings of perceived exertion. Okay, they're HPE scales. And the perceived is a bit of a problem, okay? What the research says is that if you are an experienced exerciser, that a Borg or an HPE scale of some form are pretty accurate, okay? That if I'm honest with myself and I have a lot of experience with exercising, I'm pretty good at estimating how hard I'm working. So for example, a Borg scale runs from 6 to 20. 6 means I'm not doing anything, I'm at rest. And 12, 13 means I'm working somewhat hard. 17 means I'm working very hard. 19 means I'm working very, very hard. 20 is 100%, I'd be flat on the floor. Because you can't really work at 100%, right? So, that's okay if I'm an experienced exerciser. The problem with the Borg scale is if you're a beginner, so if you are working with, if you're going to be a PE teacher, and you are working with PE students who are maybe later elementary or early middle school, don't have a lot of experience with exercising yet, pushing themselves hard, whatever, then the problem, or you're going to be a personal trainer and someone who's a sedentary individual who clearly doesn't exercise wants you to train them. The problem then with an HPE scale is that when I don't have experience at what hard means, we overestimate, right? So you know you have them working fairly light, and they're going to tell you, so they're really at an 11. And if you ask them how hard they're working, they're going to go, oh God, it's got to be 14 or 15. This is really difficult. Because they don't have enough experience to judge how hard they're really working. And anything feels hard if I've been sedentary for the past 4 or 5 years. Right? Does that make sense? And my problem, if I'm honest with myself, right, I don't know how honest I would be. Like, because I wouldn't want to work any harder, so I might tell myself I'm working very hard when actually I'm only working somewhat hard. Right? I can tell myself all kinds of stories about what I am and am not doing. My heart rate does not lie. Right? So, is the Borg scale, are HPE scales valid measures of intensity? Yes. With the right population. Are they a physiological measure? No, because it's a rating of perceived exertion. Okay? Questions? Okay. The next measure of aerobic, and all of these measures are aerobic intensity. These are not measures we use for anaerobic work. Right? So I don't use percentage heart rate max to tell how hard I'm working when I'm lifting weights. Different measure, right? These are for aerobic work. The next one you will come across is metabolic equivalent of the task, shortened to METs. Okay? Now, technically, if you had the equipment to measure what your oxygen consumption was at rest, then METs is almost physiological. It's still a bit of an estimate, but if you've got a true physiological measure of what 1 MET equals, then you're in a better position to tell me what 3 METs equals, right? So what happens with METs is that, as I said, 1 MET is the amount of oxygen that you as an individual use when you're doing nothing, right? When you're just sitting still. And then the measure of intensity is how much harder am I working compared to when I'm resting, right? So if I think I'm working 3 times harder than when I'm sitting still, that's 3 METs. If I'm working 6 times harder than when I'm sitting still, that's 6 METs, right? But to make it accurate, you would need to know how much oxygen you were using. Otherwise, again, it's kind of a guesstimate. I think I'm working about 6 times harder than I am when I'm sitting still, right? So it's sort of in between. Resting oxygen consumption for an average person is around 3.5 milliliters per kilogram per minute. But what is average, right? I can have 2 people who are the same size. One of them has much higher muscle component in their body composition, and one of them has higher fat percentage, right? Well, the person with the higher muscle percentage will use more oxygen than the person with the higher fat percentage. So again, you know, unless you can measure it precisely in the lab, you're still making a guesstimate, right? Heart rate doesn't lie. So every year I look at this information and I go, I'm still going back to my percentage heart rate max. It doesn't lie, right? The greater the MET number, the higher the intensity workload that you're performing, all right? There are other limitations with METs because it doesn't take into account changes in temperature, changes in the individual's hydration status. So the recommendation, if you find a program that you like that has METs as its intensity measure, is use those as a guideline rather than an exact. Okay. It's become a very popular measure lately. It's kind of the in measure of intensity, but I wouldn't pick it personally. Right? Resting oxygen consumption, I mean, this is an average. That can vary very widely, as I said, depending upon muscle mass, size. Your skill level changes how much oxygen you use when you're doing some work, right? So someone who's more skilled will use less oxygen than someone who's less skilled. And METS doesn't really take that into account. Okay? So what I find interesting when I'm being disciplined and I'm using my heart rate monitor, which isn't all the time, has to be said, but what is interesting is that I can go out to the walking trail that's outside of town here, right? And I have my training zone set, right, for me. So I have my training zone, and we'll come back to this idea of training zones a lot during the semester. I have my training zone set at a level that will optimize fat use and stress my aerobic capacity, right? So I've got it kind of overlapping two ideas. If I go out in the winter when it's cold, even if I'm bundled up, it is hard to get my heart rate up into the training zone. It takes well over 5 minutes of power walking very quickly to get into my training zone. And then I have to really keep an eye on it to keep it there, right? If I go out in the summer and I've got not a lot on, right? Well, I'll have long sleeves on and a hat, but you know, it's hot and I'm doing my power walking. Now, my heart rate is in my training zone in less than a minute, and now I have to keep an eye on it to make sure it doesn't go over the top end of my training zone. Right? That's why it's so useful to know, because the intensity that I'm working at isn't just I'm power walking at 4 miles an hour, right? Because how my body responds to that 4 miles an hour is different. If I'm not hydrated, my heart rate goes up faster than if I'm fully hydrated. Right? And the intensity of the work that you're doing is the key to achieving the goal of the work that you're doing. Right? If we learn nothing else this semester, you've got to understand intensity really well by the time we leave, right? Because if you get the intensity wrong, you will not achieve what you wanted to achieve with all that work you put in. Okay? So, understanding intensity, understanding how to measure intensity is crucial to goal setting and achieving those goals and motivating yourself and helping people be healthy, right? If their goal is to lose 50, 60, 70 pounds of fat, how do I help them do that? Right? Because working out really, really hard, if I'm working out really, really hard, which energy system am I using? We just did this. If I'm working out really hard, right? If I'm doing something that's very high intensity, which energy system am I using? Go on, have a try.
Is it ATP?
Okay, it might be ATP-PC. Good. What's the other option? What's my other anaerobic option? ATP-PC is system 1. What's system 2? Brand, what's system 2?
System 2.
Did you watch that lecture yet?
No, I have not.
Gotcha! Okay, system 2 is glycolysis, right? Do either of those systems use fat as a substrate?
No.
No. So if I'm working out very, very hard, I'm not using stored fat to produce energy. Right? So to understand what I set the workload at to achieve the goal the person wants to achieve. Okay? This chart, every time I pull this chart, I tell myself I need to add another column here and put the MET measures on here as well. So I do apologize that yet again I haven't done that. But I like this chart because it gives us a comparison, right? Here's percentage heart rate max. Here's percentage VO2 max, which I could use that heart rate max reserve, the Kavonen method. Here's my rating of perceived exertion, my Borg scale. And here's my just kind of verbiage, right? So this is good because now I know if I want to work at a moderate level of intensity, that's somewhere between 60 and 79% of my heart rate max. It's only between 50 and 74% of my VO2 max, and it would be around 12 to 13 on a Borg scale. Okay, so this gives me the option to compare these different types of measures. I think 3 METs is considered, I can't remember, 3 METs might be moderate, 6 METs is pretty heavy, I think. Okay? And that's really all I have on aerobic intensity for you for now. As I said, we will go back over this material later in the semester. We will talk about training zones and training programs and maximizing fat loss and all these things. That's all coming, but we have to go through our systems first and understand how the systems work and how they adapt. All right, and then we get to, okay, now we know how they adapt, now how do we train them? Okay? Questions? No? Look at it again. Okay, go over it. It's in, let me see if I have the chapter. It's either chapter 13 or chapter 14 in the textbook, so you can go and have a look at it there as well. This information is, as I said, this is what you need for your physical activity log in order to identify those. You know, I said you want to count, you're looking to try to make 150 minutes of moderate intensity or 75 minutes of vigorous, hard intensity, or a combination thereof, right? So how do I define this piece of work as moderate? Okay? Because I can measure my heart rate, or I can use the Kavonen method, or I can try to use the MET. The problem is, unless you've been to the lab and you know what your resting oxygen consumption is, that MET isn't honest. Okay? That's all I have, unless you've got questions about anything. I do have office hours this afternoon between 1 and 3. So if you think of something as this is kind of percolating in your brain, by all means jump in, come and see me and ask a question, okay? Tomorrow we will be starting aerobic metabolism, and we get to learn the next piece of the pie.